Okay, as promised, I said I would give you a way to think through how to name a compound. So the first question that you need to ask yourself is the cation H+? You need to figure out whether or not you have an acid. And from there, you have two choices. Your answer is either going to be yes, you do have an acid, or your answer will be no, you don't have an acid. From there, we're going to start with going down the acid side. So let's say yes, you do have an acid. And so then the question you need to ask yourself is, does the anion have oxygen? And again, you're going to have two possible answers. You're either going to say, yes, it does have oxygen, or no, it doesn't have oxygen. If you don't have oxygen, we're going to name it by the formulas that we learned earlier. We're going to name it hydro blank ic acid, and the blank stands for whatever the element is, so hydrochloric, hydrobromic, hydrosulfuric. If it does, you need to go ahead and you need to check the ending. Does your ending with oxygen, it's either going to end in ITE or it will end in ATE. If it ends in ITE, you're going to use whatever the stem is plus OUS and then the word acid. If the ending is in ATE, you're going to use the stem plus IC and then the word acid. So something like nitrite would be nitrous acid. Something like nitrate would be nitric acid. Now let's work our way through the other side. Is the cation H? The answer is no. So then we need to ask ourselves two other questions. We need to ask ourselves, we can ask, is the cation a non-metal, or is the cation a metal? And if we're looking at our nonmetals, we're looking at things on the right side of the periodic table for our cation. If our cation is indeed a nonmetal, then we will go ahead and name it. Name using prefixes. And these are the rules that we learned before, but we're looking at things like mono, di, tri, tetra, penta, etc. Is the cation a metal? We need to ask a follow-up question to that. We need to then ask more specifically, is it a transition metal? Our answers are either going to be yes or no. If the answer is yes, then we need to specify the charge. And this isn't all the time, but this is a really good hint. Specify the charge with Roman numerals. If it is not in the transition metals, then we're just going to name with normal rules. So if you think through this flowchart, every time you have a question to answer, it should take you down the right path to get it right. Is the cation hydrogen? You decide if it's an acid. If it's an acid, you go through the series of acid questions. If the cation is not hydrogen, then you're thinking about whether it's a nonmetal or a metal, and then you're going to go through those sets of questions. I'm hoping that this helps you with looking at the problems, and I would suggest that you write through and you use this flowchart as you're going through a bunch of problems. Now, I'd also like to take you through some extra practice problems so you can see how they're solved. So practicing some binary ionic compounds, some type 1 problems. If we have something like LiI and we want to name it, we're going to look at it. Is the cation hydrogen? No. Is the cation a metal? Yes. Is it a transition metal? No. So we're just going to go ahead and name that with our normal rules, lithium iodide. Again, AgBr. Is the cation hydrogen? No. Is the cation a nonmetal? No. Is the cation a metal? Yes. Is it a transition metal? Yes. However, silver is one of the ones that we don't need to use a Roman numeral for. It's always a +1. So we're going to name it silver bromide. Another one, cation hydrogen? No. Cation nonmetal? No. Cation metal? Yes. Transition metal? No. We're going to call it potassium fluoride. On the other side here, again, not hydrogen, not a nonmetal. It is a metal. It's not a transition metal. We'll just call it lithium nitride. MgO, again, not hydrogen. It is a metal. It's not a transition metal. So we're going to just call it magnesium oxide. Practicing with some polyatomics. So if we have NaOH, NH4Cl, NaC2H3O2, my favorite one, nacho, and CaCO3, all as formulas. Now we're going to go and name these. None of these have the cation of hydrogen. None of these have metals as, or have nonmetals as their cation. So these are just sort of normal, and none of them have transition metals. So these are just sort of some normal naming ones. So we're looking at sodium hydroxide, ammonium chloride, sodium acetate, and calcium carbonate. I forgot those sounds were in there. Again, here's some more practice with some polyatomics. Oops. Let's take a second and look at these. Notice that I didn't put the parentheses in here. Remember, they're not always needed, but I encourage you to always put them. They're definitely needed in this last one. So, cation hydrogen, no. Cation a metal, yes. Transition metal, yes, for two of them, for the iron and the manganese. So our first one is just normal, potassium bromate. Second one, I have to look at my iron. I know that sulfate, if I make notes here, so if I use scratch paper down here, I know that SO4 is a -2, which means my Fe must have been a +2. In that case, I have iron 2 sulfate. And if I look at my manganese, I have Mn, and then I have OH, which is a -1. However, I have 2 of these OHs. 2 times -1 tells me this, to balance it out, must have been a +2. And I have manganese 2 hydroxide. Practicing with some binary covalent compounds. Okay. I think I have 4. There we go. So looking here, is the cation hydrogen? No. Is the cation a nonmetal? Yes. So for all of these, my cation's a nonmetal. So I'm going to use that mono, di, tri, tetra method. So we're looking at phosphorus trichloride. I have nitrogen dioxide, carbon monoxide, and then dinitrogen pentoxide. And then practicing with naming some acids. believe I have 4 again. Okay, is the cation H? Yes, in all of these, my cation is hydrogen. Does the anion have oxygen? Well, in 2 of them, yes, I do have oxygen. So we'll start with our first 2. Without oxygen, we're just going to name it hydrofluoric acid or hydrochloric acid. Now I need to look at my ending. NO3, I know is nitrate. So if it's 8, I'm going to change it to nitric acid. And SO4, I know is sulfate, so I'm going to call it sulfuric acid. And then a little bit more with practicing with acids. Here's 4 more. Again, they all start with hydrogen. I have 1 with oxygen, 2 with oxygen. My other 2 do not have oxygen. So I look at C2H3O2. I know that's acetate. So acetate, ATE, becomes IC, and it becomes acetic acid. Here I have no oxygen. CN is cyanide. So I'm going to call it hydrocyanic acid. Again, no oxygen, and I have sulfur. So hydrosulfuric acid. And then I have NO2, which is nitrite, so I'm going to change that to nitrous acid. And the secret to nomenclature is nothing more than practicing, practicing, and practicing. My suggestion is that you go through your textbook and do all the sample problems, because that would be a great way to practice since you have the solutions there in front of you. I'm hoping these practice problems helped you see how it looks once it'll all be together.